So, like I said, we're starting probability. So this is just to, and this was a good refresher, I think, because I had to help people out a little bit with the beginning, with the fractions and everything. But like knowing that probability, when you're trying to find the probability of something, it's always, if you're like trying to figure out like the probability you're going to roll a 0, it's how many zeros did you get over the total number of rolls. Delaney, you have a question? Oh yeah, we do. I have packages. Is that what you were going to ask? Okay, guys. So when we're talking about probability, a big topic is fairness, like whether or not a game is fair. A lot of games that you grew up playing are fair. And by games, I mean like just like things like tic-tac-toe or whatever, like stuff like that. A lot of them are fair, or quite fair. And by fair, that means that you have an equal chance of winning as anyone else does, right, at the beginning of the game. Now, like say we made a game out of this dice thing, and somebody said, okay, if the difference is 1, 2, or 3, you win. If the difference is 4, 5, or 6, I win. Or say it was with 6 players, and they said, okay, one player's 1, one player's 2, one player's 3, one player's 4, one player's 5, one player's 6. Would that be a fair game? No, the person who's 1 would have a way better chance of winning than the person who's 6. Yeah, even if you just had, if I split it up right through, or sorry, not 6, 5. I guess there's only 5, but still, you know what I mean, okay? Even if we split it up through 0, 1, 2, then 3, 4, 5, it still wouldn't be equal because those percentages are not going to be equal. The percentages go down as we go up. So 3, 4, 5 would have a significantly lower chance of winning. Okay, so what are some examples of fair games? Can anyone think of any?
Connect 4.
Connect 4. That is a fair game.
Checkers.
Connect 4, checkers. Okay, I said it earlier. Tic-tac-toe is one that's fair. As long as both players play optimally, it'll come out to a tie. Okay, like things like that aren't really games, but are kind of like, they get talked a lot about in probability, or things like flipping a coin. Flipping a coin is fair, right? Rolling a die, anything that involves like a spinner is going to be fair. Okay, but then there's some things that aren't fair. Okay, so, and a lot of games aren't fair. Like, we'll talk a little bit about different types of games throughout the unit. I really like playing cards. Like something like roulette, right? If you're playing roulette at a casino, and you were just playing on black or red, there's more complicated ways to play roulette. But one way is you can just go and say like $5 on black. Okay, half the board is black, half the board is red. So you have like a 50% chance. Okay, that's a fair game. Okay, versus something like if you're going into a casino and sitting at the craps table and trying to play, the statistics are really complicated on that. Okay, or if you're playing blackjack, okay, it's not really, blackjack's one of the best games you can play at a casino. It has one of the closest odds to 50-50, but it's not quite. Okay, you have like, I think, a 48% chance of winning, a 6% chance of tying, and then like a 46% chance of losing or something. Sorry?
I forgot my calculator here. It's
Oh.
been charging since like yesterday.
Oh yeah, it's just sitting right there. Okay. There's a lot of games that aren't fair, and being aware of that is important. Okay, so experimental probability. This is what we just did. Okay, experimental probability of an event. Guys. Okay, the experimental probability of event A is defined as the number of times that event A actually occurred. So the experimental probability is that 95 out of 540, because we actually got 95 zeros. Okay, that's why it's experimental. It's something that happened in front of us, while we were doing an experiment. Okay, and then you can see here, this is kind of the notation we're going to see, and you'll notice it's pretty similar to the first unit. So you have like NA. It means the number of times that A happened. So in this case, what we're doing here, A would be rolling a 0. 0. Okay, then the number of times we rolled a 0 was 95. Okay, that's the notation we're going to use. This notation here, P of A, means probability of A. So you're going to be expected to know that. Like if you see something like that, that looks really messy, but hopefully you can listen to me right now. It says probability. Okay, probability of A. If you see something like that, P of A or P of B or P of T, it means the probability that that event is going to happen. Theoretical probability is these statistics, these percentages here that were got through like logical reasoning. It's not something that actually happened. It's like, what if we just think it out logically, what are the outcomes, what can happen here, and do it out that way. Okay? Now, what are the different ways that we can represent probability? Anyone think of some?
Factors.
Sorry?
Factors.
You mean fractions?
Fractions.
Yeah, you're right. Okay, fractions is a good one. Okay, we just use them. What other way can we represent them? There's another way on the board right now. Percentages. Okay, percentages are really common. They get used in our daily life a lot. Okay, that's something that we actually do use quite consistently, I think. Okay, and then the other one that we're going to see is decimals. So, for instance, if you had 1 out of 2, that would be a fraction. What would be the percentage for 1 out of 2? 50%. And the decimal would be 0.5. Okay, and you need to just be pretty comfortable working with all three of those. Okay, so if something is 100% likely to happen, the decimal would be 1. Okay, we're going to work with them as decimals quite often. Okay, so just getting used to that, being used to all three methods. I mean, it's not hard. It's stuff you've done lots before. Hopefully everyone's fairly familiar with it and how to go back and forth. You won't have to go, you won't very often anyway, have to turn something into a fraction, but your calculator can do it. So I'll make sure to show you guys how if you don't already know. Okay, so actually, we're not doing this. We'll do this tomorrow maybe. What I want to go over is odds. Odds in favor and against. So if we have, okay, if you have something like, has anyone, oh yeah, here, I'm just going to do a couple examples. They're not in the notes there. We're going to see it more tomorrow, but I want to get started on it today. So if you have something like 3 out of 7, which is kind of a weird percentage, but let's just deal with it as a fraction here. One thing you'll see a lot if you ever get into, I don't know, gambling mostly, but if you ever get into, lots of things use odds, I guess. That's just the thing that I think of the most. But something you'll see, if you listen about sports, they'll give you odds a lot. You'll hear people say like they have a 1 to 3 chance of winning. So it'll use a notation that looks a little bit different than this fraction. Now the big difference here, okay, there's odds and there's probability. So this is probability. Now what you're going to be expected to do in this unit is move back and forth between odds and probability really comfortably. And what I see is that students do it wrong, like all the time. So we're going to practice it a fair amount. It's not hard, it's just, I don't know why, our brains are programmed. It's something that, the problem is it's something they do when you're little. They tell you 3 out of 7, and you could also write it if you want as 3 ... 7, and they're the same. They tell you that at some point. I don't know when. In middle school, I think. I'm sure I've told kids that myself. It's a lie. Okay? That is not how odds work. Odds are not just rewriting a fraction on its side. Okay? So odds, when you look at odds, if I'm talking about, let's say this is a chance of winning. So the probability of winning your soccer game. Okay, let's say I say that is 3 out of 7. Now, odds are not 3 to 7. That's not how it works. Your odds work by saying the number of wins, the number of chances of winning, compared to the number of chances of losing. Okay, so wins ... losses. That's odds. So if I am saying you have a 3 out of 7 chance of winning, the 3 goes first, and then the other number is the number of chances you have to lose. So how many chances, if I tell you there's 7 games, or there's 7 possibilities, okay, and 3 of them are wins, how many of them will be losses? 4. So the odds in favor, this is called odds in favor, is 3 to 4. Okay, does everyone understand that system? It is not just writing 3 and then 7. You have to make sure that the 2 numbers in your odds add up. These questions are on the departmental every year, and they're actually really simple questions, and yet we're seeing our students, actually I haven't seen the results from last year yet, so we'll see when they come in, but the like broken down results. But before last year, we were seeing really consistently that students were getting these odds problems wrong. And they were like really easy problems. Like I saw them, it was like, the chances of winning were 12 out of 15, what are the odds? And like 70% of students were getting them wrong. So everyone should be able to get them right. You just need to make sure that the 2 numbers in your odds add up to the total. So let's just look at another one. And then we'll work on going backwards. So say you have a fraction like 8 out of 17. Okay? So then the odds in favor are 8 to, you put 2 dots, I know it's hard to see there because it's not very big, 8 to what? What would be the other number? 8 to 9. Now, if your odds are 8 to 9, that tells you that you're a little under 50%. What would 50% look like in odds? 8-8. Yeah. So 1-1 usually is what they say. They have a 1-to-1 chance. That means it's like a 50% chance. Either one of them could take it. For every 1 win, there's a 1 loss. Okay? Now, the other thing that you're going to be asked is odds against. So odds against just means the opposite. So we put the losers first. Yeah, I always just think of it as winning and losing because that's the easiest thing for me. Like no matter what type of fraction I'm given, I think of it that way. So I would think, well, the 8 goes second in odds against, and then the 9 just goes first. So odds against are just the opposite. Okay, it's not like a trick or anything. So if I say the odds against you winning are 9 to 8, okay, that would also mean that you are kind of like, it's not quite 50%, you're a little bit of an underdog. But only a little bit of an underdog. You're quite close. Okay, now let's work on the option. So say I told you that the odds in favor were 4 to 11. Okay, then what is the probability? Probability is 15. 4 over 15. So 15 goes on the bottom because 4 and 11 make 15. And 4 goes on top because that's the favorable outcomes. Okay, it's that easy. This is pretty easy stuff. Okay, which is why I like it. Okay, if it's odds against, you just go backwards. Okay, if the odds against are, let's say, 3 to 2, okay, my probability would still be 5 on the bottom, but it would be 2 on top. Okay, and I would encourage you, as you're working,